Okay, so the next problem. The question is the system of connected flexible cables shown in figure is supporting two loads of 400 newtons and 500 newtons at point B and D. So determine the tensions in various segments of the cable. That means the question is very simple. So we need to find the tension forces in all the strings, that is string AB, string BC, string BD, string DE. Okay, so now you can see here when you consider joint B, there are totally 1, 2, 3 and 4 forces. When you consider joint B, there are only 1, 2 and 3 forces. So always we should go with the less number of unknowns. So first we'll consider joint D. Okay, now when you consider joint D, there are only 1, 2 and 3 unknowns. So when there are only 3 unknowns, whether you can apply Lami's theorem or equations of equilibrium. After that we'll go to joint B. As there are only 4, as there are more than 3 number of forces, there are totally 4 forces. We can't apply Lami's theorem. We have to use summation of x and summation of y to get the forces. Okay, so first I will consider joint D. You can see here. First I will consider joint D. Okay, so let it be your x-axis, let it be your y-axis. Okay, so now you can see here I have told you whenever we consider any joint, we need to consider each force as tension forces. Tension forces means a force which is acting away from the joint or away from the body. First weight is acting vertically downwards, so we'll mark here the weight. This is 500 newtons. Okay, next FDE, you can see here where FDE is acting, it's clearly acting in the first quadrant. So angle of inclination is 45 degree with vertical. So this is your FDE, angle is 45 degree with vertical, right? Then FDB, where FDB is acting, or you can say FDB or FBD, both are correct. So FDB or FDB acting at an angle 60 degree with horizontal with vertical, you can see here. So this is tension force, FDB or FBD, you can call both. FDB, angle is 60 with vertical, so here 60 with, here also 60, so this is 60 degree with respect to vertical. Okay, now as there are only 3 forces, whether you can apply Lami's theorem or you can apply summation of x and summation of y. So I am using Lami's theorem here. So first we'll consider 500. So 500 divided by angle between other 2 forces, that means I want this angle. I want this angle. This angle is equal to how much? Directly 60 plus 45, 105. So sine 105, that is equal to FDB. FDB or FBT divided by angle between other 2. That means I want this angle. So here 90, in that 45 goes here, remaining is 45. 45 plus 90 is 135, sine 135. That is equal to FDE, angle between other 2 forces. Other 2 forces are DB and 500. I want now this angle. So this angle is 60 here, means remaining is 30 here. 30 plus 90 is 120, sine 120. So you can see here 135 plus 105 is 240 plus 120 is 360. That is correct. So we'll equate FDB is equal to FDE is equal to, so FDB is equal to 500 into sine 135 divided by sine 105, that is 366.0 newtons, and FDE is equal to 500 into sine 120 divided by sine 105, it is 448.28, or you can say 0.3 newtons. Okay, this is now for joint D, that is for this joint. Now I'm considering, I'm going to consider joint B. Okay, you can consider here joint B. So again let it be your x-axis here, let it be your y-axis here. Okay, so when you consider joint B, weight is acting vertically downwards. So I will show the weight here, which is acting vertically downwards. This is 500. Sorry, it is 400. Okay. One second. Yeah, it is 400. Okay. Next, FBA is acting along negative x-axis. So remember, whenever you consider a joint, treat each force as tension forces. Tension force means a force which is acting away from the joint. That means FBA is acting like this. So this is FAB or FBA. Then BC acting in which quadrant? It is acting in the first quadrant. Inclination is 30 with respect to vertical or y-axis. So FBC, it is 30 with vertical. And the last force is FBD acting in the fourth quadrant. So it is FBD or FDB. You can call it as both. Okay. Angle is 60 with respect to vertical. So angle is 60 degree with respect to vertical. Okay. Now as there are number of forces is equal to 4, so we can't apply Lami's theorem. We have to use summation of x equal to 0, summation of y equal to 0. First condition, summation of x equal to 0 or summation of horizontal forces is equal to 0. That means we need to consider only horizontal forces or only x component forces. So first we'll consider BC force acting in the first quadrant. X component is positive, so first we'll put positive sign. Theta with respect to y axis means x component is y component is cos, x component is sine. So FBC sine 30. FBA acting in negative x-axis minus FBA or minus FAB, you can call it as both. 400 acting in purely along y-axis, its x component is 0. So we'll consider FBD acting in the fourth quadrant. In fourth quadrant, x component is positive. So first we'll write positive sign here. Theta with respect to y-axis means y component is cos, x component is sine. So it is FBD or FDB, you can call it as both. Sine 60 is equal to 0. This is your first condition. Second condition is summation f of y equal to 0. Only y components. So first we'll consider BC. Okay. First we'll consider BC. BC acting in the first quadrant, y component is positive. So it is plus FBC. Now it is theta with respect to y. Y component is cos now. FBC cos 30. BA will be 0 and minus 400. Minus 400. FBD acting in which quadrant? Fourth quadrant. In fourth quadrant, y component is negative. I will put negative sign. FBD. Now theta with respect to y axis means y component is cos. Cos 60 is equal to 0. Now 400 is known, BD is known. From this equation, FBC is equal to. Okay, FBC is equal to. Okay, so if you solve this, FBC is 673.2 newtons and FBA is 653.56 newtons. Okay, this is your answer. So FBD or FDB, FDE is 448, FBA is 653, FBC is 673. Okay, so we have found all the tension forces, that is BA, BC, BD and D. Okay, this completes the problem. Okay, so the question is here, determine the tension force in the member AC and BC. You can see here, determine the tension force in the member AC and BC. Okay, so it is a very simple problem. You can directly see there are only three forces. One is 500 Newton acting at joint C. From joint C there is a member CB, there is member CA. It is clearly mentioned that we should find the tension force. So if you treat this as joint C, from joint C 500 Newton is going here along positive x-axis, right? Imagine here a quadrant so that you clearly understand. Okay, now FCB acting in which quadrant? It is acting in the second quadrant. Let it be your y-axis, let it be your x-axis. So this is FCB, and here FCA acting in the third quadrant. This is FCA. Angle is 30 with vertical, so here 30 degree with vertical. Here you can see here 50 with vertical, so here 50 with vertical. So as there are only 1, 2 and 3 forces, so you can apply Lami's theorem, or you can also use equations of equilibrium, that is summation of fx equal to 0 and summation of y equal to 0, that is summation of horizontal forces is equal to 0 and summation of vertical forces is equal to 0. Here I am applying Lami's theorem. So according to Lami's theorem, so first 500 divided by, so each force is proportional to sine of the angle between other two forces. When you consider 500, I want the angle between CB and CA, that is I want this angle, right? So this is completed from here to this is 180. 180 minus 30 minus 50, that is 180 minus 80 is 100. So sine 100, that is equal to, I will consider CB force now. FCB divided by angle between other two forces, that means I want this angle now. I want this angle. So that is from here to this is 90. 90 plus 50 is 140. So sine 140, that's equal to FCA angle between other two. I want this angle. 90 plus 30 is 120. Sine 120. So if you equate this, FCB is equal to FCA is equal to FCB is equal to 500 into sine 140, 500 into sine 140 divided by sine 100. It is 326.35, 326.35 newtons, and FCA is 500 into sine 120 divided by sine 100, 439.69 or 439.7 newtons. Okay, so simple problem. So we need to consider we need to find the tension force in AC as well as BC. Okay, so this completes the problem. Okay, so the next problem you can see here. Okay, so the question is find the value of W. Okay, find the value of W which is required to maintain equilibrium configuration as shown in the figure. Okay, so this system is in equilibrium. That means net force acting on the system is 0. That means summation of horizontal forces is equal to 0. Summation of vertical forces acting on the system is 0. That means summation Fx equal to 0 and summation Fy equal to 0. That is the meaning of equilibrium. Okay, now we need to find the value of W such that this equilibrium is maintained. Okay, now you can see here. First we need to find the theta. So theta is here. Okay, this is 90. Okay, here is 1.5, here is 0.5. So tan theta is equal to opposite divided by adjacent. So 1.5 divided by 0.5. So theta is equal to tan inverse 1.5 by 0.5, tan inverse 3. It is 71.56. So it is 71.56 degrees. Okay. Now we need to find the value of W. Okay. So either we have to use the equation summation Fx equal to 0 or summation Fy equal to 0. But you can see here I can use any one of them. Okay. So I will use summation F of Y equal to 0. Okay, so summation Fy equal to 0 means addition of Y component of all the forces. Now I can see here before using this summation Fy equal to 0, for your understanding I am drawing the coordinate system here. I am drawing the coordinate system here. Okay, so here from this joint, okay, from this joint I am drawing the coordinate system. So this is 100 Newton acting vertically downwards. Okay, now you can see here this is okay. Let us name this as A, this as B, this as okay, W is here. Okay, once again ABC. Okay, now FAB, here this is FAB. So here the value of W means here also W. That means if you apply 8 kg here, here also 8 kg is acting because it is frictionless pulley. Okay, so imagine here it is a frictionless pulley, here it is also frictionless pulley. Okay, so if you apply a weight of 10 kg here or 10 newtons here, here also it will be 10 newtons only. Okay, so this is also W, here also it is W. Angle here is theta, that is 71.56. Here also it is 71.56. Okay, so summation F of Y equal to 0. That means addition of Y component of all the forces is equal to 0. This is acting in the first quadrant. So this is W cos 71.56. Okay, plus here also W, here also theta with respect to Y axis means Y component is cos. W cos 71.56 minus 100 is equal to 0. That means is equal to 100. So W is equal to, okay, if you take W common, 100 divided by 2 divided by cos 71.56, 158.07. So the answer is W is equal to 158.07 newtons. Okay, so simple problem. This completes the problem.